Hello, and welcome to this guide on using ARTool to perform aligned rank transform. This guide is brought to you by Appalachian State University's Office of Research Consultation. For those of you not in the know, aligned rank transform is a procedure that can be used to transform non-parametric data for use in standard ANOVAs. ANOVA is an analysis which generally assumes that data is normally distributed, but ART circumvents that limitation. It's usually a cumbersome process, but ARTool streamlines it. In this first part of our series on ART, we'll be introducing the aligned rank transform procedure and exploring how to analyze non-parametric data in a traditional one-way ANOVA with two or more fixed factors. This is also known as a factorial ANOVA. In the next part, we'll be examining how to use ART on a factorial ANOVA with repeated measures, also known as a mixed model ANOVA. The ability to correctly interpret a mixed model ANOVA when used on non-parametric data is a unique strength of the aligned rank transform method. ARTool can be found on the University of Washington's webpage dedicated to it. This link will be provided in the description. We'll also be making use of a dataset provided by mathforum.org, which will also be provided. First, let's take a look at our data using SPSS. As you can see, the data is not even close to being normally distributed. However, it would be nice to be able to tell whether positions pay differently from one another, whether teams pay differently from one another, and whether teams pay positions differently from one another. Although the data is non-parametric, we can use aligned rank transform to run a factorial ANOVA and receive an accurate analysis. We'll be using ARTool to assist this process. When using ARTool, your data needs to be formatted in a specific manner. Here you can see our first column labels the participants, our last column is the dependent variable, and the columns between are the factors that are being used in our factorial ANOVA. When using ARTool, your data must also be saved as a comma-delimited or .csv file. This can be done easily in Excel by just clicking Save As and choosing from the drop-down menu here, comma-delimited. Once you've saved your data, make sure to close the file so that ARTool can work on it. Run the executable that you downloaded and find your data, check it, and click Align and Rank. This will create a new file with your aligned rank transform data. As you can see, ARTool creates new columns for each of the factors that you specified. In this case, one for team, one for position, and one for team by position. This newly transformed data can now be analyzed. Next, let's load our newly transformed data in SPSS. Make sure to close the file beforehand so SPSS can access it. In this drop-down, select Text, and select your new .art file. You'll have to run through a couple of steps to import it. In this case, our variable names are included at the top of our file. And we need to deselect space as a delimiter so that it loads in correctly. Now we can run our factorial ANOVA. Because of the way ART works, you have to run one factorial ANOVA for each ranked column ARTool creates. This is because only the results for the combination of factors for which that column was aligned can be interpreted correctly. In this case, I'll choose the variable that was aligned for the factor team and use that as my dependent variable. However, I include the normal team and position factors as fixed factors. This output should look familiar if you've run factorial ANOVAs before. However, only the results for the team factor can be properly interpreted. You'll have to run a factorial ANOVA using each of the other ART dependent variables that ARTool created to interpret the other two combinations of factors. Using aligned rank transform and ARTool is as simple as that. We hope that this guide has been helpful to you. If it has, please share it with your friends and colleagues so that we can spread knowledge about using aligned rank transform. If you're interested in learning about using ART to run a mixed model ANOVA on non-parametric data, please see part 2 of this video series.